Welcome everyone. Thank you for joining us for today's webinar, Arm Infrastructure Computing Summit 2022. The latest Canalys estimates show worldwide cloud infrastructure services spending has a 35% year-on-year growth to US $49.4 billion in Q3 2021, driven by a range of factors, including digital transformation efforts, increase in remote working and learning, and the growing use of industry-specific cloud applications. Part of conventional centralized cloud moves towards to decentralized cloud, including edge computing, to reduce latency and increase flexibility. In a variety of infrastructure options, it is important to choose a platform that ensures the performance, efficiency, security, and flexibility of complex computing workloads work. Arm Neoverse is a platform. It responds to the ever-increasing demand for the specialized processing required to keep up with the explosive growth of 5G, the Internet of Things, AI applications, as well as the rising demand to improve efficiency. It is designed to accelerate the cloud-to-edge infrastructure transformation. Today, we were very honored to invite Arm ecosystem partners to participate in the event to take you through the technical details and the use cases. The participating companies include AWS, the world's most comprehensive and broadly adopted cloud platform; Ampere Computing, the company who has designed the industry's first server microprocessor architecture from the ground up and have invented the forward-looking solution that cloud providers need for what comes next in cloud-based processor technology; and GIGABYTE, a leading manufacturer who offers a comprehensive product lined up with expertise encompassing consumer, business, gaming, and cloud system. In the first half of the summit, we invited Sammy Huang, the principal FAE of Arm, Vincent Wang, branch manager of Ampere Computing Taiwan, and Kate Yan at AWS Taiwan to give a talk. In the second half of the summit, 4 heavyweight guests from Arm, AWS, Ampere Computing, and GIGABYTE will provide the highlights of the industry, the platforms, and solutions. They will share how to increase efficiency, flexibility, and security of infrastructure and business, and share their insights on the emerging trends and the future of infrastructure. And now the summit will begin. First of all, I would like to introduce Mr. Sammy Huang, Principal FAE of Arm, sitting on my right. You want to say hi to the audience?
Hi, everyone.
All right, and now I would like to introduce Mr. Vincent Wang, Branch Manager of Ampere Computing Taiwan.
Hello, everyone.
And now I would like to introduce Mr. Kate Yan, the Solution Architect of AWS.
Hello, everyone.
And now I would like to welcome Sammy to introduce a new era of infrastructure with Arm Neoverse platform. Welcome, Sammy.
Okay. Hi, everyone. Welcome joining Arm Infrastructure Computing Summit. I'm Sammy Huang, Principal FA from Arm, in charge of promoting Arm high-performance computing technology and infrastructure solutions. Arm have devoted to infrastructure market for more than a decade. With the data evolution in the whole infrastructure, we are also continuing our investment and development. Today, I would like to share how to step into a new era of infrastructure with Arm Neoverse platform. Here is the latest update about Arm's status. As the world's leading semiconductor IP supplier, with more than 500 silicon partners and close to 2,000 licensees, Arm is sparkling the world's potential in everywhere computing happens. Now, 70% of the world's population is using ARM technology in their daily life. Our freedom and flexibility unleash the innovation which is enabling more than 200 billion chips shipped today, including 25 billion in 2020. It's really amazing. With internet booming and wireless communication rising, there are more and more devices will have computing capability and connect to the infrastructure. The mass increasing in data generation will shift the flow of data from downstream to upstream, and will also change how the infrastructure is built. Further, more computing will be developed at edge nodes, where upstream data will be filtered locally to provide real-time reaction. We foresee there will be 1 trillion connected devices by 2035. This change in the infrastructure presents an opportunity for those who think differently about how to build it. Facing the different demanding of computing needs, we address this market through ARM technology, architecture, and implement it in different CPU families. First, we have secure core designed for physical security, like banking and credit card. Our Cortex-M processors are the smallest, low-power design aimed at discrete processing and microcontrollers. Then, our Cortex-R family is designed for faster responsiveness and real-time applications, such like automotive, modem, and industrial control. Our Cortex-A series delivers high-performance computing for feature-rich operation system. Now, we formally introduce our Neoverse CPU cores, combined with our coherent mass interconnect products, enables superior performance for high core count systems. We can see 5G isn't just a radio access network, but requires to consider the full network connectivity from client to data center. The philosophy of Arm Neoverse platform is to build a cloud-to-edge infrastructure foundation for a world of 1 trillion intelligent devices. Therefore, Arm Neoverse platform have 3 key features: high performance, secure IP, and architecture. Highly customizable to fit all application needs, and wide choice of ecosystem offering. There's never been a time when more investment has been put into these IP enablement activities. Neoverse is a complete platform solution for infrastructure, not only architecture and unique IP blocks. It supports all of the major EDA platforms in development. We are also deeply engaged with the leading fabs and have devoted performance and power optimized package we call POP IP across several advanced nodes. We put a lot of effort on tools and software ecosystem. It's increasingly seamless for the cloud-native software ecosystem to bring their software stack onto the ARM platform, and for customers to gain the benefits in their cloud-to-edge deployment. We also actively participate on over 25 organizations to drive in different standards and certification, and be a key player in telco-centric organizations such as TIPS, DPDK, OpenNFV, and Linux Foundation's Acrano project. Let's look into Neoverse CPU roadmap. We have 3 major series CPU for different infrastructure market and applications. First, E-Series is designed for data and throughput efficiency and optimized around power and area reduction. N-Series is equal consideration to performance, power, and area, which is providing to be a very popular and scalable design point. Allows you to pack in more cores per TTP, whether it's a 200-watt cloud SoC or down into a 20-watt 5G base station. V-Series platform delivers maximum performance, and from a design standpoint, we are optimized around performance, even it comes with additional power and area overhead. The first generation CPU, N1 and E1, are in production and has been millions of cores deployed. Moving to Neoverse V1, the codename is Zeus. It achieved a single-thread performance uplift to 50% over N1. V1 is the first ARM-designed core to support scalable vector extension, or we call SVE. It also has two vectors of 256-bit width and native support brand 1416 data format, which will be an excellent solution for HPC, high-performance cloud, and machine learning. Moving to N2 platform, the codename is Perseus. It's based on ARM v9 architecture, the latest architecture from ARM, with enhancing security features and machine learning capability. N2 offers 40% higher single-thread performance compared to N1, while retaining the same level of power and area efficiency. Thankfully, we have no plan to stop here. We are committed to have a 30% performance uplift into 2022 and beyond. Here, we can see coherent mesh interconnect, which is a key element and technology for constructing high-performance Neoverse SoC. CMN600 has provided the foundation for scalable, high-core count performance SoC, as demonstrated by partners using N1 design. CMN700 builds on this success and provides a step function increase in performance on every factor, from core count to cache size to the number of types of memory and I/O device you can attach. CMN700 has also added CXL, which can be used to build host and endpoint devices for memory expansion and smart coherent accelerators. In such complicated system and application, it's no longer one size fits all. Our commitment to chip-level interface is critical to our position in the market. So we are investing in both CCIX and CXL. As you know, CCIX is a protocol we use for bidirectional coherent communication. And there's a lot of flexibility in how you can use it. For example, coherent multi-socket or in-package chiplet, and tightly coupled heterogeneous computing. We also add in support for CXL, which address other key use cases CCIX doesn't reach, like memory expansion, pooling, and coherent accelerator. With the high flexibility in Neoverse CPU configuration and CNN mesh interconnect technology, ARM platform offers a super scalable solution from cloud data center to edge gateway. It can fully support different computing and TDP requirements in all kinds of infrastructure applications. For example, from 5G RAN, edge to cloud. ARM Neoverse vision is to build the foundation for the next generation cloud-to-edge infrastructure with high performance, efficient, secure, and scalable ARM-based technology. It's focusing across the 4 key segments: hyperscale cloud computing, HPC supercomputer, 5G infrastructure, and IoT edge. Let me share more details about our strong momentum in these segments in the market. Ampere is one of the most important partners working with ARM and unique among processor vendors with focusing entirely on data center cloud market. This enables them to optimize their design for high core counts, high memory bandwidth, and flexible I/O connectivity. They are currently in production that support up to 80 core Arm Neoverse N1 and up to 3 GHz frequency and high-speed peripheral. Now, the 128-core Ultra Max is sampling, and we believe we will see it in the market soon. Oracle, the computer technology leading corporation, has announced their adoption of Ampere Ultra CPUs for Oracle Cloud Infrastructure, which is named as Ampere A1 Compute. Their results shows our significant value in price performance. For example, for Nginx reverse proxy, it outperforms up to 32% over the other solution. And for encoding workload, it also shows 22% benefit using Ampere Ultra. Cloudflare is a web infrastructure and security leading company that provides content delivery network and DDoS migration service. They are deploying hyper-efficient ARM-based servers with delivering 57% more performance per watt. Using ARM, Cloudflare can securely process over 10 times as many internet requests for every watt of power compared with their before. AWS was an early adopter of Arm Neoverse platform through their Annapurna Labs division. And it's been exciting to see how quickly AWS Graviton has spread through AWS service regions. To see that almost half of the new instance types made available in 2020 was on Graviton 2 is really exciting. The growing availability for AWS Graviton 2 is reflected in the uptick in our software ecosystem, where customers are deploying a wide range of workloads to get the best price-performance benefit compared to traditional CPU deployment, including major EDA tools, key database, different CI/CD developer management, and security monitoring workloads. All these key workloads can run smoothly and efficiently through different AWS instance types. Let's talk about more details about EDA tools availability in cloud for ARM with AWS Graviton 2. The silicon design flows is so complicated from front-end, back-end, to mass production and test. Think of cloud as optimizing each step of the EDA flow. Choosing the right instance type, larger amount of memory per core, or perhaps you need to cost optimize by scaling out a lot of different low-power instances. You have more choices in cloud than you have your own print EDA infrastructure. Cloud really is becoming in the new sign-off for this type of workloads. Now we could see the major EDA tools are running with ARM-based solution in the cloud smoothly. Running off the Graviton 2 and ARM CPU, the EDA workload allowed to get a better performance compared with previous generation x86-based solution. Further, this is at a lower cost. The performance uplift refers to more jobs could complete in the same time with Graviton 2 ARM-based instance. We can see this is up to more than 30% performance improvement in some of the EDA workloads. Now, our internal physical IP group EDA tool workloads are more than 80% running on AWS Graviton 2. It's not only have better performance, but also lower the cost. With the significant benefit of deploying ARM technology in the cloud, AWS is continuing their investment. A few years ago, AWS has announced its third generation Graviton 3 processor for AWS Cloud Data Center. The new CPU promises up to double in floating point performance and cryptographic workloads as well. And about machine learning capability, it also increased 3 times than before. The chip will be exclusively used in AWS Web Service Data Center. AWS also introduced the latest C7G instance, which endorsed by Twitter, Formula One, and Honeycomb.io. Through AWS and Oracle, people can now take advantage of ARM-based compute instance and start running workload on ARM in the cloud. There are more cloud service providers who are embarrassing ARM servers through our silicon partner, Ampere Computing. They have announced several Tier 1 cloud service providers who have deployed servers or plans to deploy very soon, including ByteDance, Microsoft, and Cloudflare. Several OEM ODMs like Foxconn, Inspur, GIGABYTE, and Win have announced server SKUs around Ampere's Ultra processor. Let's move on to the exciting world of HPC. We have seen how excellent ARM in HPC with Fujitsu's A64FX, world number 1 leading fastest supercomputer. Now, METI, the Ministry of Electronics and Information Technology in India, decided to adopt Neoverse V1 platform for the exascale HPC design. They joined the other 2 partners, Cypro in France and ITRI in South Korea, who are public with their support of Neoverse V1, empowering HPC SoCs. Moving to 5G, it will definitely transfer the whole industry and impact our daily lives. But it also brings new challenge like no other before. We can see it requires high speed, high bandwidth, low latency service to a growing universe of people and things. It also needs to low carbon footprint and energy consumption. I believe ARM technology delivers best-in-class performance per watt and the ability to scale computing across a broad range of network elements. It will be the best solution to solving these challenges. Let's look at the hardware silicon ecosystem. Let me introduce ARM 5G platform solutions with diverse partners portfolio. Marvell introduced product targeting in 5G market with Octeon product line for RU, CU, and DU. NXP Layerscape solution plays an important role with their small cell solution. Qualcomm, with their leading 5G technology, stepping into the infrastructure space with RU and DU platforms. NVIDIA BlueField 3 DPU and GPU is also powered with ARM CPU cores. And MediaTek integrate their 5G modem with ARM CPU platform for FWA and CPE devices. At last, Ampere server solution. Ampere Ultra Max up to 128 cores provide enterprise-class IS and virtualization solutions. In 5G software ecosystem, we launched ARM RAN acceleration library to accelerate the signal processing for 5G new radio. It shows up to 8 times performance improvement over alternative software implementation. Now, there are more than 35 partners using ARM Rail developing 5G infrastructure solutions around the world. To showcase how ARM-based platform can be used to enable a modular end-to-end 5G network, we embrace the task of working with our ecosystem partners to demonstrate what is possible. We can enable software-based networks across a variety of deployment on ARM hardware. Please visit the demo videos library at ARM 5G Summit website. We are showing 17 exciting demos working with our partners, including RAN on Neoverse, Small Cell, RIC, High Layer 1, and Core Network. Today, we are also announcing the Arm 5G Solution Labs with the goal of fostering collaboration and innovation. We are partnering with the leading telco system integrator, Tech Mahindra, to host the lab. Tech Mahindra brings a wealth of expertise in the segment with broad operator relationship and proven track record in running industrial certified labs. The lab will provide all the key building blocks, secure remote access to state-of-the equipment, end-to-end component, and all the Arm ecosystem hardwares. Across the spectrum, our partners can work on end-to-end solution integration, validation of POCs, and benchmarking activities for networking workloads. Working closely with the operator, we'll be enabling blueprints for use case that would get the solution close to deployment readiness. While the infrastructure evolution, more and more devices will need computing in different stages of data transformation, from endpoint, IoT gateway, Edge and 5G infrastructure, cloud HPC. The spec and requirements are also diverse in each stage. Therefore, the compatibility across the ecosystem becomes a critical topic. To solving the diverse demanding of different computing needs, we introduced Project Cassini in 2019 to ensure diverse solutions from the Arm partnership can deliver a consistent cloud-native software experience with a security model that protects the full range of devices. It's constructed by three key elements, including platform standardized, security framework, and cloud-native reference software stacks.
As Sammy just explained, the three pillars of Project Cassini are system-ready, security certification program, open API including PSA and Parsec, and the reference implementations for a cloud-native ecosystem. It's an initiative to rally the IoT and infrastructure edge industry to tackle key friction points in realizing a cloud-native software experience across a secure Arm ecosystem. It's amazing that there are more than 70 participating parties today. And next, Sammy will walk us through the vision of Arm Project Cassini and use cases.
This is a good example how Project Cassini to enjoy a cloud-native experience across a diverse ecosystem. Before, with different silicon partners' hardware solution, all the upper layer software need to be ported and optimized individually. With Project Cassini, it provides a standardized hardware and firmware compliant platform to make sure all the upper layer software could run on it smoothly. That we called it makes the cloud-native software just work on different platforms. With the broad ecosystem support, from this page, we could see there are more than 50 partners across different areas to support Project Cassini, which including silicon partner, OEM ODM, telco, and different software stack partners. I would also like to use this opportunity to thank all these partners' effort to make Project Cassini broadly fostering in the industry and market. Here, I would like to introduce some collaboration results with Ampere and GIGABYTE together. We could see the different alternative solutions to meet the infrastructure needs. For example, high-density solution, edge computing solution, and high-performance GPU solutions. Now, I'm going to share with you two more actual successful stories about Project Cassini. Through the example of Arm, Vodafone, NXP, and telco system, and with other partners, it demonstrates the universal custom prices equipment runs virtualized and containerized network functions, which not only save up to 60% of electricity, but also reduce cost and improves energy efficiency. Facebook Connectivity is committed to promoting simplified infrastructure solution and 5G network deployment, especially in emerging and developing countries. Through Project Cassini and Magma open source program, it supports different platforms like NXP Marvell solution to provide more choice of different low power solution with ARM-based technology in 5G core network. Software ecosystem is another critical factor to enable a frictionless cloud-native developer experience. We collaborate with a broad ecosystem of developers and make significant contribution in more than 100 open source initiatives, including CI/CD tool chain, different operation system, virtualization machines, containers, end-to-end security and networking software stacks. At last, in our increasing connected world, we are seeing ARM processors being used at all stages in the life cycle and data. ARM will continue to deliver best computing architecture for all applications and markets with performance, low power, efficiency, and security. We will also deeply cooperate with the ecosystem and our partners to expand our ecosystem to meet the needs of the future infrastructure. Thank you for your time and watching. Goodbye.
Okay, thank you, Sammy, for your introduction. And up next is Mr. Vincent Wang, the branch manager of Ampere Computing Taiwan, to give a presentation entitled Deploying a Sustainable Data Center Using Efficient Cloud-Native Processors. Welcome, Vincent.
Hello, everyone. This is Vincent Wang. I'm the Ampere Computing Taiwan branch manager. I'd like to welcome you to join this ARM summit for infrastructure. First of all, I'd like to introduce who is Ampere. In brief, that Ampere started the business in 2017. Our mission is to design the first cloud-native processor to meet the future cloud environment usage. In 2019, we launched our first 80-core Ultra processor based on Arm Neoverse IP. This is our first 80-core CPU. And then we just announced our 128-core Ultra processor to the market. That's a big step and the milestone to achieve. That's our offering to the cloud market, to the future cloud environment usage. Talking about cloud, what is Arm native cloud? What are we facing here? So you probably have no idea. There are 200 billion ARM devices is running nowadays and right at this moment, and running on 1 million of applications at the same time. So this user scenario and the user case is just our daily life. That's a smartphone in our hand. We're doing that for shopping, chatting, talking, media sharing, photoing, video recording, all of that. And also we play a lot of online gaming. We want to smart everything, right? We use that as a VR, AR kind of usage. And we are talking about autonomous vehicle. Right now we have a 4G and a 5G data network. That's a huge bandwidth over there for us to use. And all those drive the market to the next level. And those behavior user scenario is real time. Okay, require the fast networking. And we want to have the guaranteed service delivery because we cannot wait. Loading up to 5 or 10 seconds, that's not the case the user can accept. So all of that, that's the current Arm native cloud here. that we are using every day. Then talking about cloud, a lot of people don't know what's behind the cloud. It actually is the ecosystem. It's in combination of the hardware and the software. From the bottom to all the way to the workload application. From the bottom, we have a compiler with a kernel. We have all microcore firmware running on the hardware. And to the layer all the way up, start with the networking, right? Because all the devices need to connect all together. So there's a working networking there. There's a lot of protocol running on the networking. And also going up is the operating system. We have many Linux distro over there. That's to say the CentOS, the Red Hat, the Oracle Linux, all of that is the current running operation system. It's mature, it's here for many years. And it is also running on 64 bits platform right now. And going up is the container and the virtualization. Container is very important to the ARM ecosystem because such as Docker, Kubernetes, or VMware, all of that. Because that is the enablement to have all the workload application running on the ARM platforms. This is a very breakthrough compared to the legacy platforms. Then we have the language, common language. We have the Java. That's a very common usage language over there. We have the Java running on the ARM platform as well. Then going up, it is all the workloads running, right? From the database, from the web searching, from the all the engine over there. So all of that, you can see the page is just a small portion of the ecosystem. There's a lot more behind the scene. So this represents a lot of the work, hard work from engineering, from different partners, from ODM, from chipset supplier to build up this ecosystem. And in the past 40 years, all the ecosystem actually built on the x86 platforms, which that is very mature. But for future cloud usage, that's not good enough. So ARM need to develop the whole ecosystem, right, to moving forward to fulfill future cloud service and usage. So ARM is taking the lead to build the ecosystem, and we are part of it to build an ecosystem as well. All right, next I want to talk about what's the market look like in the next 5 years. From some market wisdom and research, in 2020, the overall market is like $600 billion. And to the 2025, it will be double, like $1.3 trillion over there. So if we see from the legacy approach and the use of the modern Ampere approach, we can see the significant difference over there. For the power needs, definitely if you use the legacy approach, the power will be double because the market double, so it will be double accordingly. And also for the space, which is real estate needs, it will be 6% demand over there, which means I need to find a 60% length space to accommodate all the machines over there. Then in comparison, for the modern Ampere approach, which is on based as a CPU, actually we can achieve least usage for the power and for the space, right? So we actually can save 20% power over there because all the cores we provide, all the density is over there. And because the density is higher, so actually the space is lower because in the same space that we can squeeze in more machines. Therefore, that all the density over there, the benefit and the power usage will be much better than the legacy approach. So that's really addressing the future cloud service providers' need to lower all the operation costs, the CapEx and the OpEx number down, then they can consistently in operating and provide more reliable service to the market and the end user. So what happened in the past 10 years for the cloud infrastructure innovation, right? And what is missing over there? So the innovation, we already know that there's a lot happening right now. It's machine learning, networking from 1G, 10G, 100G. Right now we can see the 400G, big data. Everybody stores the data in the cloud. The data center infrastructure changes as well because they need to have a power saving. They need to have the environmental green. The server design changes as well. The management, because a lot of servers deployed in the data center, they need to have a better management tool for that. The storage, the database. Most of all, the security, right? Everybody is online, so personal identity and the security is very important. So those things are happening right now, but the thing is not happening is the compute. Currently, still the legacy x86 architecture. So this is not really involving with the cloud needs, right? So they cannot just use the old technology for the next wave of growth and the cloud needs. So Ampere is seeing this the needs, and so we are aiming for deliver 10x the computing power performance to fulfill the future's cloud service providers' needs to save the energy, and this space. So that's the thing Ampere try to address. So what cloud they want, right? They want to have a predictable performance because there's a lot of work running today, all right? Just say 200 billion devices is running right now. So which means a lot of work coming every second to the data center. So they need to take care of that. And Arm's IP advantage is the per thread per core, which means every task coming and we can just use the one core and one thread to take care of that. And free up and then wait for the next task coming in. So the performance is pretty predictable. Okay, they can expect that the performance will not decrease over the time because all the workload coming in and they cannot handle in the right on time. Okay, that's the first advantage. The second one is the linear core performance. Right now we have 80 cores and 120 cores, and in the future we have more, right? So because we have that kind of advantage per core per thread, then they can expect that when the core grows up, the performance will follow. So they will have that in their expectation. Meanwhile, because Arm's technology, the power per core will be decreased, meaning that they can save the energy bill. So all of that provide the cloud benefit service provider that they have a consistently high performance across the user and the workload, right? Workload performance scale linearly and with the capacity, like more capacity in the same rack data centered footprint. So that's the cloud data center wanted. Then Ampere Computing coming to the place to offer the unique value proposition, right? From previous talking that there's a three good advantage over there in terms of power, in terms of space, and the quality of the service. So compare the Ampere with the legacy deployment, we actually can see that the 50% reduction for the power. And for the space, we can see 51% reduction, right? And the performance, which is the quality of service, because our performance is very linear, so it's actually 2x the performance over there. So this is a very significant power and the space reduction, right? While we're driving all the deployment at the same time. So that's the unique proposition And this is very welcome and benefit the current CSP customers. Then I want to talk about the performance, how this architect benefit, and how do we manage it and measure the performance compared with the legacy devices. Okay, so we can see that from the left side, the curve over there. So the axis is the number of cores, and the Y is the performance. So Ampere, that because the unique of the ARM IP, so we can have a very linear curve over there. So the performance will not be decreased. You can go all the way up over there. Then compared to the legacy device, they will be flat out. Okay, they cannot grow like linearly. That's because their architecture is last generation. It cannot be kept up with the new generation architecture. So if you see that if you compare with the number of cores, we actually have 2 times advantage over there. And compared to the power of the core, where we have significant 50% reduction over there. That's the advantage that ARM-based processor can bring to the data center customer. Okay, this is from the socket level. And talk about performance, we cannot not include the real cloud workload over there. So we use the 2 very compute-hungry application to measure the performance. One is the encryption. Because the encryption is related to the personal identity and security, so, and also everybody asks for the security. So we use the encryption AES 256. If you know that, it's a very powerful encryption algorithm running, which is require huge compute power to do that. Then in comparison with the legacy device with our Ampere Ultra Max, we have a significant 50% outperform with them. And next one, we use the media encoding to do the workload measurement. Okay, why is media encoding? Media encoding because everybody today, they use their smartphone to do the short video clips and share to the social media, share with the family. And also, this is a very compute-hungry application because right now, the video quality will be like 1080 resolution, and the frame rate is very high. So this is really require the CPU computing power. So in comparison, we will be outperform legacy device by 20%. Okay, so overall that we deliver like 1.2x to 1.5 more performance per socket than the legacy device. That's from real workload point of view. Then of course that's from socket level. Then next we gonna see from the rack level because that's the real world practice in the CSP data center infrastructure. So we use the common 42U rack and given the 12.5 kW power supply. Then we convert that to, okay, we can have a 20 server in the 42U rack. And then we do a quick calculation for, first of all, it's a thread. Then we install the Ampere Ultra 80 cores. So we will have the 3200 threads over there. And compared to the legacy, there's only 2240. So we will have the 44% increase advantage outperform the legacy device. That's from the thread. And next, we use the normal spec rate 2017 for the testing for performance. So we got amazing like 111% outperform than the legacy traditional server. The next things will be performance per thread. Okay, after the calculation, we can see 48% advantage over there. All in all, this is very welcome and benefit to the CSP customer because they do see the significant saving advantage over there because the performance will increase over there, and also they get their power energy saving as well. So you can imagine that if this is a very large deployment in the data center, then that number will be very huge, that to a certain big number over there. This is really big save over there. So from the rack label, that's our, we so-called the total cost of ownership. That will be very welcome to the CSP customer. Okay, so Ampere Ultra family, right now we actually already deployed to the cloud service provider, or in the US, also in some other area. And also we have a digital service provider. They provide the content delivery to the user, and also bare metal, or they can leverage bare metal and then have the anything they want to do over there. That's the so far Ampere Ultra and the Ultra Max really contribute to the CSP customer and meets their data centers needs. And next, I want to talk about the system ready program. But actually, right now, Arm is actually promoting so-called project Cassini. And system ready is right now is a part of a project Cassini. The purpose is to also build up the ecosystem, then have a seamless this connection across all the Arm platform in the hardware and the software. This is the ecosystem very important program. And Ampere joined the actually participate the system ready long ago. So actually, we are the very first one on system ready server platform certified by the Arm. And also thanks for Arm's engineers hard working to provide a lot of technical help and assistance. So we already get this platform. By the way, it's the Mountain J platform to pass the system ready certified. Okay, so I just mentioned about the Mountain J, which is you can see on the left-hand side. This is the very first one, the Ultra and the Ultra Max customer reference platform to the market. This is the platform that we're working with our ODM partner, WeWin, to have the offering 2-socket, 2U server to the market. And you can see the right-hand side, we so-called the Mountain Snow. This 1-socket machine is the machine we work with our ODM partner, GIGABYTE. Okay, so the difference is the Mountain J is a 2-socket machine, and the Mountain Soft is a 1-socket machine. They come with the 1U and the 2U chassis form factor offering. So as you can see, if they use the Ultra Max, then the Mountain J can have a 256 cores running in that machine. And our per socket to support 16 things DDR4 memory. So if it's 2-socket machine, we can have like 32 DIMMs support over there. So it's a large memory support for that machine. And for 1-socket machine, then it's 16 DIMMs and 128 cores. And of course, the PCIe lanes, we offer 128 PCIe lanes and also the C6 link for the 2-socket machine. Okay, then you can find those Ampere form in our website for more detailed information. That's our offering. It's not just the customer reference design, it's also real machine can be deployed right away. Or it's kind of plug and play machine for the server. So we are very happy that we offer this 2 machine to the market. And next, I want to talk about how Ampere contribute to the ecosystem, right? Since we already have the fundamental basic platform, Mountain J over there. So we use that as a development vehicle not just only for our ODM partner, but also for all the software development, open community developer over there. That's the standard platform that we can offer to the market. So right now we are working with, I just mentioned GIGABYTE, and Weaving is our ODM partner, and then we also extend the support to the Foxconn and Inspiron, Supermicro, and the other system integrator around the world. And we also work with the ADLink. ADLink is a very interesting partner to work with. It's actually initiated by Arm for industrial PC usage. They adopt the current HPC form factor, which is a standard form factor for an IPC. It's not just more than the IPC application. It's actually used for the autonomous application. Then actually, ADLink has a US branch office over there, and actually they have autonomous racing going on every year. So we are very excited to work with the ADLink for that application. Then going up, that is an operation firmware. We work with AMI, which is BMC and UEFI partner. They are the market leader. Most of the data center deploy the UEFI and BMC based on AMI. Then we have all the Linux distro, CentOS, Debian, Oracle, Linux, SUSE, Ubuntu. Those are very important and the OS partner for us. Then to all of that's the basic fundamental platform. Then we can offer to the world that every department can develop everything over there. Therefore, we have built up our Ampere solution portals. You can find all the information, all the development over there to join this ecosystem. That's how we expanding our ecosystem to this cloud environment. Okay, next, I want to talk about the Ampere, how Ampere addressing the challenge for the next decade of computing. Right now, it's still legacy x86 architecture in the data center, but this is the last wave of computing. This is old architecture, but they cannot fulfill the next wave for the computing because it's just too old technology. They cannot fulfill the future cloud needs in the coming future because they are not really energy efficiency. They don't really save the space over there. Okay, so they are not dense enough. They use more power. They require more power, which is not what data center want. Data center want to have this power, this space, which that they can save all the capital expense, operation expense over there. Therefore, Ampere offer a new approach by working with the Arm, using the Arm Neoverse as IP. So we already have the 80-core product, Ultra launch in the 2020, and we have this year we have the Ultra Max. We just announced in production is 128 cores in the market, and coming future we will have the even higher core count product to the market. Okay, it's based on the TSMC 5 nanometers processor, which they have more power over there. And we see this market as we cannot wait every 4 or 5 years to have one CPU to the market because cloud time is on the annual cadence. Okay, so we offer CPU in every year. Okay, so one CPU every year. So data center customer can see that, okay, they can plan ahead to meet their future requirement in terms of performance. They want to have a scalability. They want to have energy saving. They want to see all the prediction and also that they can fulfill in the future cloud service. That's very crucial to them. So this is my sharing of presentation today. So thank you to stay with me.
Thank you, Vincent, for the detailed introduction. And next, I would like to welcome Cage Yan, the Solutions Architect of AWS, to give a presentation titled Accelerate Different Workload Scenarios with Cloud and Edge Computing. Welcome, Cage.
Hello, everyone, and welcome to this session. The topic is about accelerate different workload scenarios with cloud and edge computing. My name is Cage. I'm the Solutions Architect in AWS. For the agenda, first, I'm going to talk about our new Graviton instances, some of the customer success stories, and also we've seen around Graviton, the momentum and Arm software ecosystem. Our next generation Graviton 3 processor. I'm going to address this on how that comes together to form the 7th generation of EC2 C7G instances. For the edge computing, I will talk a bit about our new launch AWS Outpost servers, and then the summary of the session. Let's start with the silicon innovation at AWS. The first is the AWS Nitro system, where we took components of a hypervisor. That's the piece of software that takes a big machine and cuts it into the virtual machines, and started moving it onto special purpose chipset that accelerated I/O, which raised the bar in security on that host processors for your processing. The other two areas we have been investing in are the Graviton 2 and Graviton 3 now, which is powerful and efficient host compute. And also our machine learning chips, Inferentia for inference and Chaining for the chaining, which both cut the cost of inference and chaining in your apps and are more efficient than other solutions. So why we build our own chips? Building our own chips really lets us innovate quite a wide variety of layers on behalf of you faster, raise the bar in security, and also deliver more value. And those are the reasons that we end up doing this. On the innovation side, being able to build the silicon, the server it goes into, and having teams that write the software for that all under one roof means there's faster innovation, and we can cut across traditional boundaries. We also can build chips for our own needs. We can specialize them for what we are trying to do. We don't have to add features that we don't want to, and also we can just build them for the things that we think are gonna provide most value to our customers, and ignore the ones that really are not. The third is speed. We get to control the start of the project, the schedule, and the delivery. We can parallelize the hardware and software development and use the massive scale of our cloud to do all the simulations required to build a chip. And then lastly, for the operations, we have a lot of insight into operation running EC2. And we can put features into our chips to do things like refresh the firmware to address an issue or enhance functionality without disturbing the customer running on the machine. Arm processors are ubiquitous around us. For years, they have powered the phones and the tablets that we use every day. They are also starting to show up in laptops with Graviton servers. Our Graviton processors have targeted optimization to reduce cost and the power consumption, which means they are less expensive to operate, and we get to pass that cost savings onto you. We are now in our 3rd generation of Graviton. We announced the first one back in 2018. In 2019, the second with a substantial performance increase. And for now, we are here with the 3rd generation with another substantial increase. As you can see from this slide, Neoverse N1 outperforms across diverse workloads in several performance benchmark scenarios. Take AWS M6G and M5 for example. In overall performance gain, M6G delivers 40% price performance compared to x86 M5 instance, and also 20% lower the cost. I will talk a bit more in a few minutes later about the performance. Today, we have Graviton instance available in 12 different types and across 23 different regions. We started with the M6G instance, and since then, we've expanded the portfolio of instances with the compute-optimized C6G and the C6GD. In 2020, we announced C6GN, which adds 100 gig of networking elastic fabric adapter and a higher EBS performance. We have all R6G and R6GD instances for memory-intensive workloads, and customer can do and say, we're able to pack so many things into an instance if we only had some more memory. So with that, we created the X2GD with 16 gigs of memory for every vCPU. We have a burstable type like T4G for free trial at the moment. We announced 3 different instances in re:Invent 2021. The first are 2 storage ones, IM4GN and IS4GEN, which provide a lower cost per terabyte of SSD storage in EC2, or the best price performance in EC2, depending on what layer want. And we also have G5G, which is the first time we've taken a Graviton CPU and coupled it with an NVIDIA GPU. As I mentioned with the IM4GN, we have up to 40% better price performance compared to our i3 instances. And with IS4GEN, we have the lowest cost per terabyte of any of the storage-focused instances. Both of these features are new Nitro SSD, which leads our custom design SSD where we talk to customers and we ask them that will make their storage instance better. And a lot of the answer we got were, if you can reduce the tail latency of I/O requests, not necessarily increase the I/O or increase the bandwidth, but just reduce the tail latency, they can push more requests through the system and the mid-layer SLA goals. And that will lower their cost, and so that's what we focus on here. One of our customers that's been trying the IM4GN and IS4GN is Splunk. Splunk is a leading data platform provider and is designed to investigate, monitor, analyze, and the cost on data at any scale. And when they moved from i3 and i3EN to our new Graviton-based instance, they saw a 50% decrease in search runtime, or up to a 50% decrease in search runtime, and a significant price performance improvements here. The other instance that we just announced is the G5G. Here, we have an NVIDIA T4 Tensor Core GPU paired with a Graviton CPU. And together, this makes the most cost-effective GPU-based platform in EC2 for graphics applications, machine learning inference, and one of the big use cases we found here is Android game developers wanting to do the development, testing, or streaming of the games to end users. One of those is Canonical. Canonical has a product called Mbox, and they've been using these instances. They found they can stream 55 different stations from one machine at 30 FPS, and it ended up being 20% less expensive than the instances they were using previously. So, how can you use the Graviton? Graviton is supported by major Linux distributions like Amazon Linux, Red Hat Enterprise Linux, SUSE, Ubuntu, and others, as well as FreeBSD and NetBSD. And of course, containers. We have a lot of customers running containers on Graviton, building multi-arc containers that supported by the x86 and Arm, and deploying them to either Graviton or x86 instances. by running Kubernetes themselves using EKS or ECS. And in November 2021, we also announced Fargate support for Graviton as well. Another exciting announcement that we have here is for people who are looking to develop HPC applications on Graviton. The NVIDIA HPC SDK is going to be available as part of AWS Parallel Class this year. And the list gives us two things. First, HPC application really require specialized compiler and analysis tools because they are looking at visualizing thousands of processors and hundreds of nodes. And the second is optimizations. An HPC compiler might be more aggressive in certain optimizations than a general purpose compiler would be, especially around the loop vectorization, for example. And so, in this year, the NVIDIA HPC SDK will be available as part of AWS Parallel Cluster for Graviton, not just for our GPU instances, but even for all of our Graviton instances, and you will get seamless integration with our EFS software. And different benchmarks have shown as much as 80% higher performance when using those compilers versus GCC and G4Chain. Perhaps the easiest way to utilize Graviton is to use some of our managed services. We now have support for Graviton in DocumentDB, Amazon Aurora, RDS, ElastiCache, MemoriDB, and the most recently Neptune. And in a lot of these cases, actually Graviton's become the default. If you don't specify a specific instance type, you end up getting a Graviton instance. Also in our analytics tools, we have OpenSearch and EMR that both support Graviton. A few months ago, Lambda announced supporting for Graviton as well, and also both Fargate and the Elastic Beanstalk now also support our Graviton instances. Also, a couple of days ago, Amazon FSx for Lustre and OpenZFS announced that part of the last solution will be Graviton-based. There's also some other exciting news a few days ago that SAP HANA Cloud, which is a fully managed in-memory cloud database as a service, is also working with us to port or to power SAP HANA Cloud on Graviton processors going forward. A few weeks ago, we also announced Graviton Ready program, and the list is certified partner solutions for us on Graviton, where they are supporting offering, including operating systems, platform services, security, monitoring, CI/CD, analytics, and also cloud services. And these partners run QA of their software and offer optimized products that are equivalent, be it a Graviton system or another system. And the list make it easy for you to discover agents and other solutions that will just work out of the box easily. We've also seen a huge number of customers adopt Graviton, from large enterprise to startups, across different verticals and segments and geographies, either directly through EC2 instances or through the managed services that I just mentioned. Typically, people start by migrating single workload, and they see that actually the effort might be less than they expected, and they get some price performance benefits, and they started moving increasing number of workloads. We've seen people like Discovery, who use Graviton-based instance to reach 175 million viewers during the Tokyo Olympics. Epic, who's running Fortnite and the Unreal Engine on Graviton. Formula One, who found it 40% lower cost running computation fluid dynamics on Graviton. And the Lyft, who use a combination of Python and Go, and saw 30% better price performance. Sometimes people ask about the scalability. Who is using Graviton at the scale? And the most customers don't want to discuss about the scale that they are using with any particular instance type. But during Prime Day, back to June 2021, Graviton powered 12 different called retail services, including one called Database. Now, Database is the database that also does computation in it. And in terms of scale, they ran over 53,000 instances during Prime Day. So that can give you some ideas of the scale which Graviton can be adopted. After talking about the Graviton in the past, let's talk about our new Graviton 3. On the upper right corner of this slide, this is a picture of Graviton 3 CPU. You can see here that there's something a little different about it. It's got 7 different die in that chip. And I want us to do in a couple minutes later. But there's over 50 billion transistors in Graviton 3, up from 30 billion in Graviton 2. So we put a lot of compute into that die. Overall, there's 25% higher performance per core versus Graviton 2. And Graviton 3 is the first system we have with DDR5 in our data centers. Graviton 3 runs at a slightly faster clock, but it gets most of its performance by extracting more instructions per cycle, or IPC. There are 30 to over 50 billion transistors. Most of them went into cores. We made the core a lot bigger. It's got 2x wider front end, a much bigger branch predictor that predicts branches for larger workloads, almost 2x wider dispatch, a 2x larger instruction window, twice the single instruction, multiple data performance, and also support SVE and the bfrost 16. There's 2x the memory operations, including some enhanced prefetchers, and twice the number of outstanding transactions from each of cores. There's 2x the ALUs and the multipliers. And the multipliers are wider. That means the things like RSA TLS session negotiations are a lot faster. And finally, we have both point auth and confirm that the pointer was signed, which stops attacks like return-oriented programming and RNG instruction. One thing that makes Graviton quite different than the other instance that we offer is that every vCPU you get as a full-blown core. There's no SMT or hyperthreading. None of the resources like the L1 or L2 caches or parts of the pipeline in the core are shared. So on one of our x86 instances, you have these hyperthreads or simultaneous multi-threads, and it has instructions for the pipeline. They contain in the execution resources and in the caches, and sometimes this is good in that you get to fill in some of the holes in the execution stream. Other times you end up just extending the execution. On our Graviton instance, since every vCPU is a physical core and there's no SMT, there's none of that interference in the core or in the caches. One thing customers love about the Graviton 2 was there were no NUMA domains. NUMA stands for Non-Uniform Memory Architecture. It really is the question of, is the path from a core to memory the same? Or is there a kind of near memory or far memory? And most people don't think about that. Don't know how to determine where their data versus where their processing is. So they leave it up to the OS. And the OS has really imperfect information. It doesn't really know. So when you get the case that the cores and the memory are collocated, things are great. And when they are not, it gets slower. So we decided we wanted to do multiple die. We started with the premise of we were gonna put all the cores together. So there was no NUMA domains, and then we stitched them together with a mesh that runs it over a 2 gigahertz and has more than 2 terabytes a second. We then distributed a cache throughout one mesh. It's 32 megabytes, and that cache, along with all the caches in the cores, means there's 100 megabytes of user accessible cache on the chip. Then we enter our DDR controllers. Those are the 4 chips you saw on the slides. They're in the picture on the right. These are DDR4 4800 controllers, and they have over 300 gigabytes a second. Theoretical memory bandwidth. And just like Graviton 2, it's easily accessible memory bandwidth. You write simple loops on the cores and you get 80% of that without any heuristics or spatial instructions. And just like Graviton 2, all the memory is also encrypted. We also support PCIe up to Gen 5. And then that's what those 2 bottom dies are for. Now, I talk about the CPU, but we have end-to-end ownership here. And in the data center, you have racks. And in the racks, you have servers. And for every rack, it's usually about 42 U tall. And this is a certain amount of provision power for that rack. In an ideal world, you will fill the rack and you use all the power in the rack position. That would be the most efficient solution. However, with a lot of systems in our data centers, we can actually fill the rack. They consume all the power before they consume all the space. So we run out the power first. But with Graviton and Graviton 3, we run out space before power. We would like to put more in the rack. At least if we build with 2 sockets, so what can we do? Well, we took a kind of basic server design that has 2 sockets. In our case, a natural core and say, why do we actually need 2? Let's build a package, the motherboard, and the entire chassis to fit 3. So we have 3 Graviton 3 side by side. That increases the sockets per rack by 50%. It comes closer to the power requirements we see from other vendor solutions. And our latest generation of Nitro core is able to manage all 3 of those sockets simultaneously. With that, we better balance the space and the power we consume at each rack position and end up delivering a more efficient solution. So with that, we have our 7th generation of EC2 instance with Graviton 3 CPUs, DDR5 memory, and then we found that they use up to 60% less energy for the same performance than some of the comparable EC2 instances we have. And this means they are going to have the best price performance in EC2 as well. There's a preview for C7G now, and you can sign up for it at the URL here. So what about the performance? Let's talk about Graviton performance for a few minutes. So the first thing that I'm going to share is Spec CPU 2017 Red. So this is where we're running a copy of Spec CPU on all of the vCPU in the system. And we think that's closer to a real performance by running all the vCPUs than only running by sample one. Since people don't typically buy a large machine and then only use one of them. Spec contains a bunch of benchmarks, including things that do compilation, Sudoku, solving weather prediction, and others. And on the integer side of that, you can see we have 27% higher performance versus Graviton 2, and on the FP side, almost 60%. For the rest of this, I'm just gonna compare versus Graviton 2 versus Graviton 3. And for this one, I'm gonna talk about load balancing with Nginx. Nginx is a load balancer or a web server as well. And here, we have a load generator. We are using the open source load generator work to generate 512 clients worth of HTTPS connection through Nginx and then to load balance that onto a number of web servers. The load generator is fixed and the web server is fixed as well. And we just choose, are we gonna run a C6G.2XL or a C7G.2XL instance for Nginx? In doing this, we saw almost a 2x increase in performance on a 2XL size. When you get to larger size, like 4XL, it gets a little bit less, but still is a huge number. Similarly, we look at the Node.js application. In this case, Acme Air. It's a simple application that does flight scheduling. And we ran one copy of Node.js per vCPU. Use NGS as a reverse proxy. Fix the database and the load generate again. And we find 37% higher performance on NGS from Graviton 2 to Graviton 3. There's a lot of video being transmitted across the internet and encoding that as a large portion of many cloud-based workloads. And so here we use libx264 to encode some uncompressed video with a very slow preset for the highest quality. And we see 49% more frames per second are encoded on the Graviton 3 system versus the Graviton 2.1. Let's talk about F1 use cases. Part of that is they do a lot of computation fluid dynamics to see how the cause and the downforce works on the cause, and how it disturbs the air behind the cause. Now, F1 already saw that the C6GN instance saved them around 40% by doing the CFD simulations on those. C7G reduced that runtime by another 40%. It's 40% faster, and so Pat Simmons, who's the CTO of Formula One Management, think that C7G will be the optimal choice for all their CFD workloads. Last but not least, I want to talk a bit about machine learning. Here, I'm looking at natural language processing workload using a BERT model and a question and a answering task. Using a BERT model and a question and answer task for machine learning, the first is bfloat16, which gives you the same width as an FP32 number and less precision. And we have twice the same width. So we combine those together, we end up seeing about 2.5x higher performance. On this BERT workload, and if you were looking at the CNN like ResNet, it's closer to 3x or even over 3x. So overall, customers on Graviton 2, which based on Neoverse N1, already see significant benefit on many applications. For example, more than 1.4x on general compute, 1.5x on EDA and simulation tools, 1.5x on web servers and the reverse proxies. By leveraging Neoverse N1 platform, customers can gain benefit in many different kinds of workloads. Beyond just kind of numbers that we've looked at, AppGains has gotten to test a C7G instance, and they say they are suitable for those demanding latency-sensitive workloads, while providing significant price, performance benefits, and expanding what's possible in Fortnite and any Unreal Engine creative experience. Similarly, Twitter tested a C7G instance as well, and they used a number of benchmarks that they found to be representative of their internal workloads, and found between 20 and 80% higher performance, as well as reducing tail latencies by as much as 35%. And lastly, Honeycomb. These are the Honeycomb so that they use about 30% fewer instances on the C7G over a C6G, and they also got 30% reduced latency. So I encourage all of you to sign up for the Graviton 3 preview program to test your workload. After talking about the Graviton use cases on AWS Cloud, now let's talk a bit about the edge computing, which is AWS Outpost servers. At AWS, when you think about the app continuum, we also need the infrastructure and the service continuum to help you run application wherever you need it. Starting off with AWS regions that serve most customer use cases, and then extending out to the fourth parts of the edge with IoT and the disconnected environments. We are also building out services in the middle tier, where customers need AWS infrastructure and the service on premises, in large metro centers near end users and at the edge of the 5G networks, to reach mobile devices. When we look across this continuum, AWS regions serve the needs of most customer use cases. For the middle tier, Outposts provide AWS infrastructure and the service in customers' on-premises environments and is the building block for AWS local zones that bring AWS services closer to end user in large metro centers and AWS wavelengths that delivers AWS service to the edge of 5G networks. And for works that need to run in remote locations where there's a lack of consistent network connectivity and no on-premise availability. There's AWS IoT, Greengrass, and the FreeROS and the Snow family of devices for ROC environments. We always heard from customers' requests on this kind of hybrid cloud scenarios. So we launched AWS Outposts to general availability at re:Invent 2020. In re:Invent 2021, we also launched AWS Outposts servers. The servers can be integrated to your existing space. To make this simple, you can order rack multiple servers that can fit into existing rack space. For example, racks with network switch equipment, 2 SKUs that are 1 and 2 rack units tall and fit into EIA 3110 90 inches wide racks. Each server will have lower power draw and lower bandwidth requirements than smallest Outpost racks do today. Now, with 2 new form factors, Outposts can help customers operating across smaller sites, like for example, like retail stores or enterprise branch office that run point of sale systems, security monitoring, network administration, smart display, and develop next generation facial or voice recognition to customize their customer experience, and also integrate to data lakes and ML models, aggregating insight in the cloud. So for the healthcare providers, they can do a range of hospital and clinic sites of varying sizes. And also they can use latest tech to raise patient images. And then they can process medical data quickly, but benefit from cloud tools and long-term storage as well. For factories, warehouse, and the distribution centers, they can leverage Outpost servers to run the compute at the edge, and also power automation, integrate with IoT data, monitor system, and provide feedback to operators. Let's take a look at Outpost one-use server's configuration. With AWS Graviton2 processor, which is C6GD, it contains up to 64 vCPU, and also 128 gigabyte RAM, and 2 plus 1.9 terabyte NVMe SSD inside. It also includes 10 gig Ethernet port and Nitro security key. You could install it easily within your existing rack in data center. So what can we do with the AWS Outpost servers? By using the AWS Outpost service and the smaller form factor configurations, you can run compute applications at the edge for low latency and local processing. For example, you can run virtual machine with EC2 instances. Each instance will have instance storage that can be used for AMI launches and data volumes. You can also deploy containerized workloads using like Amazon ECS or EKS. And you can network with Amazon VPC to introduce logical separation between workloads and secure communication with the workload that spans the region and your site. Last but not least, we expect this will be a good option for IoT workloads. Support to IoT Greengrass for IoT Messenger and also SageMaker Neo for inference at the edge. So in summary, Graviton3 delivers up to 25% higher energy performance, around 50% scientific performance, and also media encoding performance, and over 2x faster machine learning performance. Our new C7G instance extends the price performance better than our Graviton2 instance, and they are in preview now. They will be in GA in the coming months, and you can sign up for the preview here. For Outpost servers, you could learn more detail from the web link mentioned here. And also, if you would like to know more information about Graviton, here are some useful links that you could dive deep into, including Getting Started Guide, Performance Runbook, and also blogs on our landing page of Graviton 2. Thanks again for your time to join this session, and be well. Bye-bye.
Okay, thank you, Cage, for the informative sharing.
Thank you.
Coming up next is the highlights of our webinar. I believe you're just as excited as I am about the coming up panel joined by 4 elites in the industry. And now I would like to welcome and introduce the 4 guest speakers. Okay, so first of all, I would like to welcome the moderator, Mr. CK Zhen, the president of Arm Taiwan. Welcome, CK.
Hi, everyone.
And now I would like to welcome Mr. Robert Wang, the managing director for AWS in Hong Kong and Taiwan. Welcome, Robert.
Hello, everybody.
And now I would like to welcome Mr. Vincent Wang, the branch manager of Ampere Computing Taiwan. Welcome, Vincent.
Hi, everyone.
And now I would like to welcome Mr. Akira Hoshino, the product planning director of Networking and Communication Business Unit of GIGABYTE. Welcome, Hoshino.
Hi, everyone.
And now I would like to give the floor to the moderator, CK.
Today, we are very honored to invite Arm ecosystem partners to participate in this event to take you through the industry, technical details, and the use cases. The participating companies including AWS, the world's leading cloud platform provider, Ampere Computing, a startup focusing on the server and the edge processors, and the GIGABYTE, a leading manufacturer with rich experience in server products. So, Robert, I'm gonna begin from you. As a leading CSP, what is the biggest challenge you see to deploy the massive servers in the data center?
Yes, DK. For AWS, security is always job number one. It means that priority of security is higher than anything else for us. For other challenges like cost optimization, reliability, performance efficiency, operational excellence, and of course, sustainability. So as the first cloud service provider, started our business providing services to the global customers from 2006. As everybody knows that we started our business from retail, but now as we're serving more and more industries, there are more enterprise-focused needs. So in order to help our customers and fulfill all the needs from different verticals, our infrastructures need to be adjusting ourselves as well, so as to continue provide the innovation, technology, and capability. So, based on the challenges of security, scalability, availability, we have decided to design our own chips starting from 2014, right? It's a chips that we call Nitro, right? This provide better virtualization framework and hardware, so as to be able to work with a different hardware architecture. So up to this moment, Nitro is already the 4th generation of chips. It allows AWS to have a faster speed and then provide extra value to our customers in order to save their cost and then make it easier for them to leverage other services that AWS provided, like among the 4,075 instances we're providing that handle different workloads, such as general purpose and the burst computing demands, high power computing, with the different combinations of compute and then storage, right? And we work very hard to develop our own chips so as to increase the so-called price performance ratio, right? As we've been working very closely with ARM on different generations of Graviton processors, right? It gives us, for example, AWS Graviton 2, it gives us, our customers, a 40% better price performance for all workloads. So aside from that, I think lots of audiences probably know that as well, that aside from all the computing power based on gravitons that we provide over the cloud, we have a different type of hardware that also work with the different processors on products that we call Outpost. It's a 42U server stack machine, right, that can be landed in on-prem environment that work together in a hybrid, very well in a hybrid environment, while we also have hardware like Panorama, like a Monitron, static extended, all the way to very front end to enable a lot more smart solutions, IoT-based solutions. So, also touch base a bit about sustainability, right? So, through all this, our self-designed hardware, processor, equipment, we be able to really optimize, all the power consumptions, form factors, features that actually, allowing us not to consume or over-consume all these energies. And then last but not least, I think globally there's a huge demand and needs for all these customized chips, right? So through all these customized chips, we be able to, come out ADAPS Trainium, right? That provide a better efficiency, allowing all the developers to increase the outcome, the better outcome on the AI and machine learning training needs. So I think these are all our, say, challenges and the things that we have done when we're scaling all this cloud computing all the way from cloud and then into very and at the edge in terms of these hardware computing needs.
Yeah, that's really that's really good sharing. Well, as Robert mentioned, Amazon began from internet retailer, right, and now becomes one of the biggest cloud service provider. And well, it's not an easy path. So there are a lot of innovation, along this journey. Our collaboration with AWS, roughly 10 years. Yeah. So the innovation around not just the main processor, but also from the like product like Nitro. So so if you look at the sustainability, it's really important to come up with a decent computing platform with a way lower power consumption. So really good sharing. And next, Vincent, as a server processor maker like Ampere, what is the major challenge that you see in this infrastructure space?
Okay, CJ, that's a really good question. Ampere is the ARM-based processor company. So the challenge we are facing, I like to address from two ways. Okay, one is from technology. Second is from the ecosystem maturity. Let me start with the technology first. What do a data center asking and want? Okay, that's determined by the end user's behavior. What kind of service they are using every day, right? We are talking about the shopping, the communication, right? Online streaming, chatting, live sharing, social media, all of the service that the data center need to provide. Therefore, what do they ask for a processor? What is that we need to provide, right? So under that circumstance, we need to provide like consistently high performance, okay, usage power of the core, and workload linear core performance. Okay, that's a requirement for nowadays a CSP customer. So that's the challenge we are having at this point, right? So anything that the service data center need to provide, then we need to fulfill that from the CPU standpoint of view. Okay, that requires the CPU to hit the desired performance, meanwhile consume the least energy, and then the legacy x86. The other major challenge is the ecosystem maturity, right? Which in the past 40 years, all the ecosystem build is based on the x86 architecture. So a lot of software, firmware, spend countless hours to put engineering, to put effort on it. So that's if we want to do the conversion from the legacy to a nowadays CSP environment, then the overall data conversion cost is very time consuming and also the very costly. So it's not just only the physical hardware. The firmware and the software are needing to innovate and evolve all together with the physical hardware. Then it's required first to have the innovative processor design for the modern cloud. Then all the hard effort and all of the things that the put into. Then Ampere also, we have been building the firmware and the software internally and work with the partner from AMI, Red Hat, Oracle, VMware, and many other more. We also work with the open source community for Linux boot, OpenBNC, EDK2. Those partners are spending equal amount of effort to overcome the challenge to support chipset suppliers like us, ODMs, and the CS customers. So with those efforts invested, the ecosystem support is already here. CSP customers do benefit from the innovation of the hardware and the software altogether. More and more new applications are developing and developing in the cloud more easily. Okay, thank you.
Thank you, Vincent. Well, so this is a really good sharing. Who would have thought that, has become a really strong challenger in these server and infrastructure spaces back to 10, 20 years ago. But as Vincent mentioned in his sharing that, we began from nothing, and we are really fortunate enough to have a lot of support from the ecosystem partners, software partners, to drive this innovation all the way to support the need for all the consumers. So next, Hoshino-san, would you like to talk about the challenges in this space and how Gigabyte gonna step up to overcome those challenges?
Okay, and Gigabyte is one of world's first ARM64 server makers. And since 2013, we have developed ARM64 servers for over 8 years. Back in 2013, Intel's Xeon 86 occupied almost all the server market, not only the server hardware follow-up processor design guide, but also the whole server ecosystem, including BIOS, BMC firmware, OS, add-on device, drivers, and applications. All optimized and tuned for the best performance with Xeon 86 architecture. I must say that when we first started developing for ARM64, it was a challenge. For the software layer, an ARM64 server is totally different from the Xeon 86 solution. So we had to enable each device driver and make OS vendors compatible with the ARM64 solution one by one, case by case. We paid a lot of resources and time to solve each bug and each issue that came with using an ARM solution. Without a collaboration with OS vendors or the device vendors, including networking and storage, we won't be able to solve anything. Because it's not only building the hardware, but also building the software layer and the ecosystem.
Thank you, Hoshino-san. Well, if you look at ARM, back to 30 years ago, we are just begin our business in a bank in Cambridge. Now, all of you been building your products on top of Arm Neoverse. So, did you mind to share what is the motive, for your company would like to build your innovation on top of Arm Neoverse? So, let's begin from Robert.
Yeah, thanks, CK. So, I think from our point of view, ARM architecture is really providing flexibility. That enable us, right, be able to optimize the performance and then saving the cost that based on a different type of workloads that customer needs, right? So it also provides, higher efficiency, better performance, and then higher expandabilities on container or serverless applications. So, as a very customer obsessed organization, right? We focus on customer needs and then enriching the entire ecosystem is something that we really love to do. So far, AWS is providing over 40 types of computing instance that allows the different type of customer workloads and then business needs. As the cloud computing move forward, right, more and more customer workloads are migrating over to the cloud. And then we found that, customer is definitely looking for better price and performance ratio type of products. So we found in order to better help our customers to provide better price performance ratio products addressing the needs of different workloads, we really need to rethink and then walk all the way into the core of computing, which is chips, right? That's why, we started to design our own ARM-based chips. And also in the past, most of the time, customer focused on mostly general purpose workloads. So the computing workloads is staying for a long while on, the general purpose processors. But the cloud computing also changed the landscape, right? So nowadays on AWS, even for all those really, really rare workloads, right? We be also able to enable them, hundreds of thousands of the needs. So under this kind of scenario, right, the specializations of hardware becomes very, very important and critical for us. And then by doing so, we found that, we be able to drive the cost down and then consume less power compared to the traditional hardware. It's only 10% out from that. So we really see all these optimized or say specialized solutions be able to realize lower latency and then provide better performance and then lower cost to our customers.
Wow, are you serious? Only 10% of the original power consumption. That is amazing. That is amazing. Well, Amazon is famous for their one of the slogan. There's a customer obsession, right? So with that in mind, so providing flexibility to your customers and providing a better price performance. And with the specialized hardware, that is a continuous path for AWS, and we are committed to support you guys to continue to drive the innovation in this journey. So, Vincent, you want to talk about this?
Yeah, sure. Ampere is a processor design company. We need to be very careful to select our partner. Then why we select ARM? Well, it's a non-brain selection decision, right? We look at it from three reasons. First, ARM's architecture has leadership data center performance, which is more efficient than the legacy x86, right? Second, TSMC has a processor technology leadership, and most of the ARM-based SoC are producing TSMC. Right, so we can have a better cost performance through the TSMC. And third is the software ecosystem already mature. Amazingly, like over 200 billion ARM-based chips are deployed to the market, right? That makes the largest ecosystem in the world. So major OS support, container, virtualization, language, development tool, and the new emerging applications are running smooth and efficient on all the ARM platforms. This brings the capital operation cost benefit to the industry, which meet the trend of energy saving with desired performance, long-term software capability, and the total cost of ownership. From research, we found that the cloud market will be double in 2025. If still running on a legacy x86 machines, the energy consumption is double for sure, and the space consumption is 1.6 times. In comparison, running Ampere, which is ARM-based processor, the energy consumption is about 80%, and the space consumption is about 60%, which is being consumed in 2020. The reason is simple. Ampere ARM-based processors are architected to be cloud native under the same performance level. Ampere Ultra and Ultra Max processor consume this energy and still have a lot of headroom for the workloads. Lower power automatically result in the better rack density, and in processor reduce the data center footprint. Okay.
Good point, Vincent. Well, I think it's really important to talk about ARM processor with energy efficiency point of view. But you mentioned you use Arm Neoverse. Part of the reason is to save the spaces for your end customer, like a data center. That is a really unique perspective. As a startup in this infrastructure space, Arm is committed to support startup like you with a huge ambition to revolutionize this market. So hopefully with a new processor and a new process at the foundry, gonna bring you up speed to drive the innovation and a good technology to service your end customer. So Hoshino-san, in terms of in terms of your selection of ARM, as you mentioned earlier, it's been a while. And can you tell me the journey that you are on? You are with ARM?
Well, we start our first ARM64 solution with a Permichael XGen and an Annapurna solution in 2013. And after that, we also created a new product with Caviar ThunderX solution. We also had our Qualcomm-centric solution as well. And currently, the newest solution is Ampere Ultra and Ultra Max. We built a very wide lineup based on Ampere Ultra and Ultra Max solutions. GIGABYTE is always trying new ARM solutions for servers. Certainly, we need to invest capital in R&D resources, production costs for the numerous manufacturing stages, and the ecosystem. But we believe that ARM64 server can take advantage of TCO. Also, for IoT device, we must operate efficiently, which is something ARM architecture excels at. ARM64 server will create a new area in ARM server market and let us achieve big growth in business, leveraging our leading position. I need to mention about the ARM System Ready program because it's really important for GIGABYTE. This certification is vital to let our customers know that our certified server systems can use generic off-the-shelf operating system to just work. So our customer will have extra confidence to deploy a GIGABYTE ARM server using the Ampere lineup.
Thank you, Hoshino-san. So wow, I'm amazed by your pioneering ARM-based silicons. And well, if you look at the Arm Neoverse, last year we launched Arm Neoverse V1 and the Arm Neoverse N2. The Arm Neoverse V1 is the first Neoverse processor supporting scalable vector extension (SVE) that's suitable for HPC, machine learning, and high performance cloud. So we would expect to see more adoption of Arm Neoverse in the future. So next question is, right now we are in the early of 2022. Do you mind to share some of the new breakthrough in the new product line you offer so that your customer will be benefit from? Let me begin with you, Robert.
Yeah, thank you. So AWS Graviton processor is our own design chips, right? It provides customers with a much better high price performance ratio computing power, and then it can be applied into different use cases and scenarios, including web application, microservices, high power computing, AI, ML, video transcoding, EDA, gaming, and so on and so forth. And then it also support AWS managed services, including Amazon Aurora, Amazon Elasticsearch, Amazon EMR, AWS Lambda, Frage, and so on and so forth. That allows customers can really utilize and then leverage and then enjoy all the benefits that Graviton processor be able to provide. So, let me give you a couple examples. One is that a Taiwan startup called Ampere CV, right? Are really dedicating to providing a real-time AI video analysis and recognition system, providing security center for a better and complete surveillance solutions, right? So they're using currently the Graviton 2 to increasing the entire system efficiency and lower down the cost. For example, they're simultaneously processing 80 cameras, right? With the same amount of data, right? They found that using Graviton-based M6G CPU, right? It's actually decreasing 80% of amount of data compared with the previous M5 instance. That means CPU performance increasing 18% as well. Right. On the price side, Ampere CV is also using Amazon EC2 Spot instance. While it's actually effectively expanding the business, it also helped to save the cost. So ended up, it drops the server unit price down to 20%. So the overall price performance ratios are therefore increasing 47.5%. So it's becoming really competitive, for their overall competitiveness on the same solution. Another example is very famous Formula One car racing, right? So while they're racing car in the physical world, increasing efficiency is also a very big and high mandate for them, right? So they keep exploring the ways to optimize their overall cloud cost. So by using Graviton instance, they found that for their CFD workload, they found that the overall costs are reduced up to 40%. So therefore, they're planning to introduce more Graviton instances into their overall computing needs. In 2021 November, right, we're also launched the Graviton 2, working together with the NVIDIA T4G Tensor Core GPU on a G5G instance, right? The G5G is the first instance that being used in the big cloud platforms based on Arm architecture, right? That helps the Android, for example, Android gaming, streaming, with a much better price performance ratio, right? By using G5G, Android developers can, use the ARM-based GPU instance, encode, and then, render all this graphics and stream all this game video over the network onto their mobile devices, and that, simplifies the entire workload, drive the cost down to, 30%. So, aside from that, G5G is also good for AI and machine learning scenarios, and using the NVIDIA ARM-based GPU to help all the developers enhance their machine learning and AI development work.
So speaking of Formula One, we are sort of in I would not say lockdown, but we now do not travel as often as we did, right? So we expect one day that Robert can take us to watch the Formula One game. But it's a really impressive product line, and the G5G bring the cloud gaming to this CSP. I think that's impressive. And also, here I share one little story about the Ampere CV that Robert just mentioned. There was one day, probably a couple months ago, when Ampere CV they visit our Taipei offices. We talk about our collaboration in their AI solution, in their camera solution, and in just about we wrap up that meeting, I asked them, did you use cloud as well? They say yes. And I say, which CSP do you use? They say, no bueno, we choose Amazon Web Services. And then I asked them, did you know that actually we have ARM instance at AWS. He said, yes, we are using this. I'm stunned. Well, really? He told me, well, yes, they are a company that is pursue of innovation and the new technology. So the engineer give it a try after the suggestion from AWS as solution architect, and it only took them just one day to easily migrate the existing workload from the existing instance to the M5G instance, as Robert mentioned. So it's easy, and it's I would say it's seamless, right? So it's a good example of onboard CV. And Robert also mentioned EDA. And well, I've been in EDA business for a couple of years in my early age. I still can remember back to maybe many years ago. The hassle for EDA business is it requires really high performance computing. And if you look at the implementation, you look at the simulation flow. Actually, it's sometimes is really hard to predict the hardware consumption level of your project. At this month, it could be you need an additional 10 servers, but let's say in downtime, maybe you just don't need that much more. So with the deployment of Arm's implementation flow to cloud, that is really a huge innovation for the entire industry. So really, really good sharing from Robert. So Vincent, you want to talk about the innovative product from Ampere?
Yeah, sure. Ampere started business on the October 2017. The company, the pure goal is to have the first and aiming for the modern cloud environment to have a cloud native processor to the market. So after 2 years engineering, developing, and hard working, we launched our first ultra processor, which is 80 cores, in 2019, and it is now shipping volume to the customer. This is our first major stone and goal achievement. And we just announced our second generation, which is Ampere Ultra Max production to the market last month. Ampere Ultra Max is the very first 128 cores CPU running at the 3.0 gigahertz speed and supporting the 128 PCIe Gen 4 lanes and up to 4 terabytes DDR memory support. It's a LGA package and the socket pin compatible with the Ultra 80 cores processor. So which that the design can leverage the same multiple design, depends on the different performance needs and the workload needs to use the match numbers of cores and the different speed CPU. And of course, Ampere Ultra processor are based on the Arm Neoverse IP, and it's Arm v8.2 compliance cloud native processor, which is on the TSMC 7 nanometer processor. It delivers the performance of the modern cloud workload needs. For our first 80 cores Ultra 2 recent 128 cores processor, in the near future, we're gonna have more than 128 cores for the next generation. So Ampere is addressing the needs in several ways in terms of performance and the core count, energy and the efficiency, predictability, I/O capability, and the open source community support.
Well, it's hard to imagine Ampere is just such a new company, but with such big marketing momentum at this stage. And also Vincent talking about 128 processors in just one CPU. That is amazing. That will require a huge amount of the engineering effort to put those those high performance CPU into just one silicon. So next, Hoshino-san, you want to talk about the new product of Gigabyte?
Certainly. Let's take a look at one of our product design for Ultra. The G242-P32 is the purpose built for the NVIDIA ARM HPC developer kit. We enabled with two NVIDIA A100 GPU cards and two Bluefield 2 DPUs on this platform, and passed the NVQA test for the MPerf. We created the SKU of the P31 to support 4 A100 cards in G242 series. It was the first ARM64 server tested for MPerf. The gigabyte server for ARM in MPerf was about 2:1, so about 100 equal to the Z86 solution. Now that means for GPU solutions, that ARM server can just work for customers. They can have two choices, Z86 and the ARM64. Another of our products, the E252-P30, will be one of our key products in this Edge series. And it was the first ARM64 Edge computing server, which is based on Ampere Ultra platform. It features a single processor and a short depth chassis that is less than 500 millimeter, with front I/O for easy access. And the last gigabyte server want to share is the H262-P16. It is the first worldwide high-density server based on the Ultra Max solution. With the half-width motherboard design, there are still dual processor and the 16 DIMMs available in each of the 4 nodes. That means up to 1,024 cores in this 2U form factor.
Wow, really impressive. 1,000, more than 1,000 cores. Wow, it's amazing. So we really look forward to run the project on the Gigabyte Edge server and cloud server in the near future. So OCP is an initiative to apply for benefits and for open source and open collaboration to hardware and rapidly increase the path for innovation and near and around the data center. So Vincent, can you please share about the meaning of OCP for the ICT industry and to the wider ecosystem?
Sure. OCP is such an importance. So Ampere is actually joining OCP as a platinum member. So just last month, Ampere announced the contribution at OCP Summit 2021. Our first Mountain Jet platform, which is based on the Ultra processor, now is OCP accepted. This is the platform that we have been working with our ODM partner for a while, and also released the design file and the spec for this server. So everyone in OCP community can take advantage of this innovation that we have made and then build upon it. It's the first ARC 64-bit server to show the transition from legacy to the next generation modern compute. Mountain J support up to 256 cores, which is 2 Ultra Max. So lots of compute for cloud-native workloads. And not just the CPU and the physical hardware. It's also about the firmware and the software. That's the key piece of putting it all together. We also contribute back the firmware and the software to this platform. We have also been building open source Linux boot, OpenBMC, Tiano Code, EDK2, and many more. Those pieces are very important part of enabling the OCP community. It's important that we really spread that out across the ecosystem and make it available for everyone. We want to contribute and affect the transaction. Without it, it's a little bit hard to get going.
So now you just announced the Mountain Jet in last month. So when are you going to take us to Mountain Jet? Yes, well, so OCP is a really important program that unite a lot of ecosystem partners into this group to drive the innovation around the infrastructure space. So, Hoshino-san, I'm also aware that Gigabyte is one of the pioneers driving the open standard. Can you share this perspective from your point of view?
Sure. In Ampere lineup, we designed our server's I/O with OCP 2.0 and OCP 3.0 slots on purpose. And these slots can provide alternative networking and storage rate functions according to customers' demands. And this flexibility is appreciated as networking needed by end users is so diverse, and the customers has more freedom when it comes to server design and upgrading.
Thank you, Hoshino-san. So now the importance of the open standard is unequivocal. So ARM is also driving the standard on the infrastructure space, like server ready and system ready that earlier Hoshino-san talked about. So last question to these gentlemen. We are aware that we only have one planet. We are not sure that we are able to find another planet that is habitable like our globe. So any initiative from your respective company to drive the sustainable world for the human beings?
Yeah, thanks, CK. As we all know that, it's everybody's responsibility to save the planet, and then the entire human being has also set a Paris Agreement, right, aiming to drive the carbon emissions down to net zero by 2040, right? And Amazon has already announced that back in 2019 September that we will be realizing this target 10 years ahead of a Paris Agreement. That means you will be driving the carbon emissions down to net zero by 2040. Aside from that, we're also using 100% renewable energies for our operational needs. We're setting a target originally, right, to reach the goal by 2030, but now we're aiming to hit that by 2025, 5 years ahead of that, our original goal. We'll also raise a 2 billion fund that as part of our corporate social responsibilities that help the entire world finding all possible solutions to reach the goal. So aside from all this, we're using more and more renewable energies for our own facilities or our operational needs. For example, we're buying 100,000 electric vehicle from Rivian, right? So by using electricities, right, is really largely reduce the carbon emission. While for example, in building up a data center, we're using low carbon concrete. Actually, Amazon is becoming the largest renewable energy buyer in the world. Aside from that, we also announced several projects buying the wind power, right, from the sea, including we have a project in Europe, in South Africa, and Japan. So actually, cloud technology do help the customers reduce their carbon footprint, right, by migrating lots of servers onto the cloud. Really save your power consumptions. And while lots of on-prem servers, while using the powers, right, your utilization. Because in order to keep the business feasibilities, normally on-prem server capability need to be over-provisioned. Then that means you have lots of surplus capacities from time to time. It's unused, right? It's consumed power still, right? So using cloud on-demand services is always being kind of optimized. So based on some research company, for example, there's a research company called 451 Research. By using AWS data center, right, the efficiency, power efficiency, is actually 3.6x compared to what will be happening in the general enterprise environment. While with the same mission and the workload, the carbon footprint will be reduced 88%. So that's a huge decrease. So I think aside from that, we have really highly committed to the ESG, to the sustainabilities, by also working closely with ARM, developing the Graviton processors generation over generation. For example, our Graviton 3 processors compare with our previous generations of processors, actually reducing power consumption for over 60%, right, as a part of our ESG contribution, working closely with ARM as well.
Wow. So we really look forward to to see the Rivian electric delivery vehicle in Asia in the near future, and 88% of the carbon emission car, that would be a huge save. So I'm also made a commitment in September 2020 to reduce 45% of the carbon emission, and to reach the net carbon emission by the year of 2030. So Vincent, from a fabless design house point of view, can you share more about your vision in this decarbonizing compute?
Yeah, of course. This is, as a global citizen, this is the topic we cannot run away, and we need to seriously do the commitment over there. So we are really hyper-focused on the reduction the carbon footprint. Then Ampere was found to focus on one thing, which is deliver a sustainable solution to the large server customers. The vision is to deliver a sustainable solution. Start with the architecture and the design team, right? Because we are doing the silicon design. Where they optimize the architecture to deliver best performance in the watt metric. This results in significant saving in reduction, not only the power dramatically, but also the data center real estate requirements. As discussion during my presentation, to meet the 2x revenue goal, the cloud service provider will end up consuming more than 2x power and 60 more real estate if they continue to deploy the legacy platforms. Using Ampere ARM-based processor will allow them to meet their revenue goal by consuming a fraction of the 2020, but not 2025 power and the real estate requirements.
Yes, it's really important to cut the electricity consumption and also the space consumption with the new solution like Ampere Ultra and Ultra Max. So Hoshino-san, what is the point of view in terms of the sustainable growth?
Yeah, power efficiency is always very important to us. And Ampere solution can deliver power efficiency, compute density, and by optimizing processors for the highest performance per watt and the lowest power per core. Ampere Ultra and the Ampere Ultra Max are the most efficient data center processor today, and this allows cloud service provider to deploy more cores and more CPUs, meaning more capacity in same rack while reducing the data center footprint. And for our servers, there's also EU regulatory requirement for product environmental declarations that become effective March 1st, 2020. This regulation specifies energy and materials requirements for server and storage products. To meet this regulation, we use Platinum power supply as our standard feature today. But after July 2023, we will upgrade all our servers to be even more efficient with Titan level power supply. That means that approving power efficiency is something we constantly enhance in our product lines.
Thank you, Hoshino-san. As we are approaching the end of our event today, I would like to appreciate all the participants being here. We hosted a series of seminars to share ideas and solutions for various applications with our Arm ecosystem since around 2 years ago. The reason we choose infrastructure as the topic for the beginning of 2022 is because while we are stepping into the golden age for the semiconductor industry. More power will be consumed to produce more electronic devices. And in response to more computing needed for digital transformation, however, we just have one Earth. While we are talking about decarbonizing compute, one of the most effective ways to go about decarbonizing compute is through increased power efficiency. It also puts Arm in a unique position to help our ecosystem to maximize the positive impact of their solutions while minimizing the environment footprint. Next time, when you create a project, please consider to choose the processor architecture and the platform with better energy efficiency to reduce carbon footprint, to achieve climate stabilization, which is what we have been working with ecosystem partners for decades. We hope today's sharing can help you to get a better understanding about the solutions, the chance of infrastructure development, and deliver the value-added experiences to empower your business. Thank you very much for investing your time with us today. See you next time.